Hello, we're CTRL+ALT+ELITE and we're doing the Intel Challenge.
The Intel Challenge aims to mimic the steps of photolithography and silicon die manufacturing at a much larger, more budget-friendly scale. The challenge consists of using an Arduino to control stepper motors attached to micrometer screws, which push a small platform in the X and Y plane respectively. We can then use a digital microscope to view the platform and measure the distances that are traveled, because the distances that are traveled are far too small to be viewed with the human eye. Once we achieve movement and control of the plane, we can then implement our own systems, which can be applied to a real-life scenario of photolithography and silicon die manufacturing when we scale our systems up.
Our initial plan was to code the Arduino to control the step motors, and then build a GUI which would make it easier to control the Arduino, which is eventually connected to it, and then run the program using the GUI to control the step motors with the Arduino.
The first big roadblock we ran into was related to our lack of experience when it came to older Arduino hardware. We were having some really bad interference with the wires with our first setup of the circuit. And if you move your hand anywhere near the wires, the motors would just start to vibrate uncontrollably. So we decided to rewire the circuit and install an older Arduino software, and this entirely mitigated the problem, letting us move forward.
The second roadblock we hit was when the Arduino was unable to read the commands from the Java code, which means it could not pick up the commands every time we clicked the directional buttons on the UI, as the serial was not properly working. We thought of ways around it and tried debugging it, but we could not, and eventually found a better and easier tool to make an UI called MegunoLink, and this helped us out a lot. And finally, switching to MegunoLink instead of Java saved us a lot of time and was also so much easier, as it was directly connected to Arduino and we didn't have to use serial. This led to a much smoother and faster completion of it. Here's a quick demonstration of how we control the step motors with the UI we created with MegunoLink. We have the directional buttons to move in directions we want it to. We also have the number of steps we can enter, and each step is equal to 1 tick, and 1 rotation is 200 ticks. And we also have the home button, which returns it back to its initial position. So clicking up should move it 0.5 millimeters in its full rotation, and right should move it 0.5 to the right, and down should move it 0.5 to the left, down, and then left should move it 0.5 to the left, which it does. And at the end, clicking the home button should bring it back to its initial position, and there it is.